Okay, today I wanted to work two different examples of polynomial inequalities on how to solve them. Hopefully this will help any confusion you may have when you're working your homework. So for this example, if you notice, we have 2x squared plus 5x is less than 18x minus 20. And the first step when we're solving polynomial inequalities is we want everything to be on one side of the inequality sign, and we want to have 0 on the other side. So my first step would be to bring everything over to one side. I'm going to bring it all over to the left side. So if I do that, I'm going to subtract 18x to the other side, and I'll add 20 to the other side. And here we go. That leaves 0 on the right side. So let's combine anything, any terms that are common. We have 2x squared. The 5x and negative 18x can be combined into negative 13x plus 20 is less than 0. So here we have a polynomial set less than 0. So our first step, once we've got it in this form, is to try to factor it so we can find our boundary points. So let's see if we can factor this. Let's do 2x and x, maybe 5 and 4. Let's see if that works. Let's check ourselves. That's negative 5x minus 4. That looks like it factored. Okay, so once we get it factored, we want to solve it, set each factor equal to 0 and solve. Just like we were solving an equation, we would get x equals 5/2. And this one gives you x equals 4. Okay, these two values we call boundary points. Some people call them interval endpoints, but they're important because what we're going to do is we are going, I'll do it over here, to make a number line, and we want to plot these two values on the number line. So we have 5/2, just in order, and 4. Now this is like an x-axis here without the y-axis. So this is our number line, and these two interval endpoints or boundary points are going to divide the x-axis up into 3 different intervals. I like to separate the intervals with lines. Some of the other examples you see, people will put closed dots or open circles. I like to do the lines. So the question is, am I going to put a dotted or a straight line? The way you can tell is we come up to our sign. We are solving this. We want to know where these values are less than 0, but not equal to 0. So if we're looking just for less than 0, we're going to put a dotted line. Okay, now let's think about this. We just solved these and found 5/2 and 4. Those are the two values of x that make this polynomial equal to 0. Okay? We don't want to know where it equals 0. We want to know where it is less than 0. So that's why I drew a dotted line. A dotted line is simply there to tell me that when I write my solution at the end of the problem, I do not want to include these two numbers in the solution. Therefore, in interval notation, I'll put a parenthesis. But let's say the original problem had an equal sign on it. This is only if. This is not the actual problem. We would have come over here and we would have drawn straight lines there, and that would have told us to include these in the final example. But I'm going to erase this because that's not our problem. We are only dealing with less than 0. Okay, so what we do is we take each interval. We're going to pick any point inside the interval. Now this is 2.5, 5/2. This goes all the way to negative infinity, so we can pick any x inside this interval, anything you want to. I'm going to pick 0. What you can do is you can plug 0 into your function. Let me write it. I'm going to write it up here just so we can see it again. Here's our factored form. Right, this is the polynomial. So our question is, when is this greater than 0 or less than 0? So we take x is 0 over here. You can just plug it. Sorry, that looks bad. 0. Okay, plug 0 into the function. So when x equals 0, if you plug it into the function, we're just going to deal with positives and negatives. I don't care what the number is. I just care, is it positive or is it negative? So when I plug 0 into, 2x minus 15, so you think about it, 2 times 0 minus 5 times 0 minus 4, okay? 2 times 0 is 0. 0 minus 5 is negative 5, right? And then 0 minus 4 is negative 4. So we're going to use these sign charts. Basically, this represents a negative number times a negative number. And when you multiply two negative numbers together, you get positive. Okay, that means this whole region is positive. Okay, so I chose 0. If you had chosen the number 1 and plugged it in, you would have gotten a different number, but you should have gotten a positive number. So anything you pick from there to plug in, you should have gotten positive. Okay? Now I'm not going to be writing these numbers every time. I'm just going to use the sign chart. So let's do our second interval. So remember, 5/2 is 2.5. So let's pick something between 2.5 and 4. I'm going to pick 3. So when I plug 3 in, right, I plug 3 into 2x minus 5, that's 2 times 3 is 6. 6 minus 5 is 1. That's positive. When I plug 3 into x minus 4, you get 3 minus 4 is negative 1. Negative. So for this one, we have positive times a negative, and we know that that equals a negative. Remember, anytime you're multiplying or dividing, an odd number of negatives gives you a negative. An even number of negatives gives you a positive. Okay, so this whole interval is negative, and then let's do the last one. We'll pick something larger than 4. You can pick 5 or 6. Doesn't matter. We plug that one in. We'll do it right here. When I plug in 6, I get 2 times 6 is 12. 12 minus 5 is 7. It really doesn't matter. All that matters is it positive? And then when we plug in 6 here, we get 6 minus 4 is 2. Positive times a positive is a positive. Okay, so here's my number line. I have it complete. This number line tells me everything I need to know. Okay, 5/2 and 4, those are the 2 points that make the polynomial equal to 0. Everything between the two, between 5/2 and 4, makes the polynomial negative, which is the same as less than 0. And then we have the outside intervals. Both of those intervals make the polynomial positive. So now once we have this finished, we're ready to write our answer. Let's go back. What are we looking for? We want to know where this is less than 0. Okay, now less than 0 is a negative number. So we are looking for the negatives. All right? So our negatives tells us this is my interval. These are the x values that make the interval negative. So my answer will be 5/2. We have to write it in interval notation to 4. Very important, the parentheses we use because we had dotted lines. If those had been straight lines, we would have used brackets. This is my answer. Okay, guys, for this problem, I chose this out of the homework because sometimes it can cause some confusion for some people who are working their homework, so I wanted to work it as an example. The problem from the beginning is already set up as less than 0, but if you notice, you have negative x squared. Things are out of order. Sometimes that causes some problems for people when they have to factor it. One way to look at it that you could work it is if you wanted to make that x squared a positive x squared, you could take all three of these terms that are set up on the left, the 30, the 30x, the 225, and the negative x squared, and you're going to add and subtract them to the other side, to the right side. That would leave a 0 on the left side, but that might work it out where at least things will be positive for you. So that's what I'm going to do. I'm going to take, let's see, I have 30x. Let's write it out. See if it makes sense to you. So basically, if I want to take x squared, to the other side, you add it to both sides. And same thing for everything. So if I did that, when I brought x squared over, that's positive x squared. Right? If I brought 30x over, right, that would be minus 30x. And lastly, if I brought 225 over to the right side, you're going to add that to the other side. So that'd be plus 225. Okay, that leaves 0 on the left side. Okay, to me this is just one way to make it a little bit easier to factor. So we're ready to solve it. Our first step is to try to find the boundary points, and you do that, of course, by trying to factor the polynomial. 225 is kind of big, but 225 is 15 times 15. So if you have minus and minus, that ends up factoring. You have negative 15 plus negative 15 gives you 30, negative 30. So here we have it factored. Okay, you're welcome to keep it this way if you want to. Since it is x minus 15, you could choose to write it as x minus 15 squared. This really doesn't matter. Either of them will work for you. But we have it factored, and so what you do is you set each factor equals 0, which in this case they're the same factor. So to find our boundary points, if you set that equal to 0, you get 15. Okay, x equals 15 is my boundary point. Or like I said, sometimes you hear it called interval endpoint. So 15 is the big one. All right, so that's when you come over and you make a sign chart. This is not too bad because you only have one number to plot, 15. Okay, so we have to make the decision. Do we have straight or dotted lines? Because I'm looking, when I was looking for where is it greater than but not equal to, that tells me I do a dotted line. Or if you feel better, you could always write it as an open dot. It's the same thing. An open dot and a dotted line represent the same thing. But we have 2 different intervals. So let's test a point in each interval. Let's see, to the left, I'm going to pick anything less than 15. I could pick 14, 13, 12, 10. I could pick 0. I could pick anything negative if I want to, but I can plug it in there. So if I plug 0 into my polynomial, which remember my factored form, I'm going to write it up here just so we have it nice and close. X minus 15 squared. So if I plug 0 in here, I get 0 minus 15 is negative 15, but you square it. When you square it, that becomes positive. So this whole interval is positive. Okay, so if I do the other one. Let's pick something larger than 15. I'll pick 16. If you plug 16 into the same polynomial, you get 16 minus 15 is 1. And you square it, you get 1. So it's positive. So basically, you think about it, any number you get, you're going to square it, and that's always positive. So everything's positive. Okay, so here's my number line. And now we need to look and think about what the answer is. Okay, so let's go back to our original problem. Right here, we are looking to see, let me turn it to red, looking to see where is it greater than, right? So we want this to be greater than 0, right? Greater than 0 are positive numbers. So you come down here and you say, okay, positive, positive. So everything's positive. So for my answer, this interval, right, these are all the x's that make that part less than 15 positive. And then everything greater than 15, these are x values, make the interval positive. Okay, so we have to write this in 2 different intervals because if you notice, 15 is a dotted line, which means this cannot be included in the answer. So my answer would be, first, I have negative infinity to 15, parenthesis because of the dotted line or open circle. Union, pick up on the other side of 15, and we go to infinity. That's my answer.